Bon. Bonjour, Madame, Messieurs. And this is the only French I will speak in this section. We are here to attend the doctoral PhD presentation of Ms. Thais Luiz Santos. And first of all, I have the honor to confirm that Ms. Thais Thayanne Luiz Santos was approved to defend her thesis in the discipline Sciences de l'Univers at the University of Toulon and the Marine Science Program at the Universidade Federal do Ceará in Tropical Marine Sciences. The thesis is the first product, and this is a very important thing, of a co-tutelle agreement between the Universidade Federal do Ceará and Université de Toulon. We hope this agreement will give us more fruits and more students will participate on that. So this is the first one, so we have probably some complications on presentations and things like that, which is typical of the first step of this program. May I present the jury? The jury is composed by two rapporteurs, two members from the two universities, Universidade Federal do Ceará and the French University, and the two advisors, one from the Université de Toulon and the other one from Universidade Federal do Ceará. The two rapporteurs are Professor Mélanie DAVRANCHE. She's a lecturer in Geosciences of the University of Rennes. She has been a junior member of the Institut Université de France since 2012, and her major research interest is the biogeochemistry, especially on the interactions between metals and organic matter. The other rapporteur is Professor Carlos Eduardo de Rezende, a full professor at Universidade Estadual do Norte Fluminense, in Rio de Janeiro, Brazil. He is a researcher of the National Research Council of Brazil, and his major interests are the geochemistry of organic matter in tropical aquatic ecosystems and environmental contamination. The two representatives of the Brazilian and French universities are Professor Florence VOUVE. Professor VOUVE is a lecturer of environmental chemistry and analytical chemistry at the University of Perpignan. Her major interest deals with the environmental chemistry of pollutants, water quality, and applied spectrometry methods applied to water quality and aquatic contamination. The other one is myself, Professor Luiz Drude de LACERDA. I'm a full professor at the Universidade Federal do Ceará, and my major research interests are on tropical ecology, coastal and marine ecosystems. I have a little emphasis on ecosystem functioning and environmental contamination. The two advisors, one playing the music, as usual, Stéphane MOUNIER, from the Université de Toulon. Professor MOUNIER is a maître de conférence of the University of Toulon in environmental chemistry and spectrometry. His major interests are on the biogeochemistry and organic matter interactions in natural ecosystem, and he has a large experience in tropical ecosystem also. He's also responsible for the French part of the co-tutelle agreement. And finally, the Brazilian advisor, Professor Rozane Valente Marins. Professor Marins is head of the geochemistry biogeochemistry laboratory at the Institute of Marine Science at the University Federal do Ceará. Her major interests are in cycling of carbon, nutrients, and trace metals in tropical and estuarine and marine ecosystem. And Professor Marins is also the responsible for the Brazilian part of the co-tutelle agreement representing Universidade Federal do Ceará. So, Ms. Tahis will have about from 40 to 50 minutes to present her work, and further we'll proceed with the jury evaluation. So we shall pass directly to the presentation. So I invite Ms. Tahis, please, to take the stage, and after we start our discussions, starting with the two rapporteurs, which will provide their reports and ask any other questions. If they won't, followed by the representative of the two universities, and finally a word from the two majors. So, Ms. Thais, please, up to you now. Thank you very much for your attention.
Good morning. Good morning. I would like to start to thank the presence of the board, my advisors, my friend telespectator. I'm Thais Santos. I'm a PhD student on the co-tutela regime between the Universidade Federal do Ceará in Brazil and the Université de Toulon in France. And I will show the result of my project titled as Geochemistry of Trace Metals and Organic Matter in the Equatorial Estuaries in Brazil Northeast, under the advice of the Professor Rozane from LABOMAR, Brazil, and the Professor Stéphane MOUNIER from Lyon, France. So the trace metals are a great concern because they are persistent in the environment and they can be accumulated over the food chain that can cause toxic to the aquatic organism and pose a risk to the human health because because the consumption of the commercial organism. Uh, Commercial organism. So the natural source of trace metals can be for the suspension of soil and sediment and the surface runoff. And the anthropogenic source can be from port activities and domestic and industrial influence. And the study of spatial distribution of characteristics of these contaminants along the estuary can give us important information about anthropogenic pollution of these contaminants in these environments. And the organic matter, it's a complex heterogeneous mixture of organic molecule that is decomposed, transformed along the estuaries and can vary in the reactivity and to his ecological roles. And due to his great amount in the Earth's surface, it can act as it give us an important role in the global carbon cycle. The main source of the organic matter to the soil can be from allochthone, that is a terrestrial humic substance derived from vegetation and animal detritus that is carried out from the river to the estuaries. And there is also the autochthone source that is more related to biological activity that happen in the water column, such as microbial oxidation and the primary productivity in this system. And they also the anthropogenic source that's related to organic synthesis or the human excretion. And when these trace metals and organic matter enter the river to the estuaries, the biogeochemical process and the physical chemical parameters, such as pH, salinity, and potassium redox, can act as an important factor of this partition and mobilization along the estuary. And when the trace metals enter in the system, the colloidal fraction can be dissolved to the truly dissolved fraction and also can be absorbed to the suspended perimeter and that can be set to the bottom and can also form inorganic complex and metal organic complex that has efficient complexation capacity that is kinetically non-labeled to the environment. And this interaction between the organic matters and metals is influenced by the surface charge and the functional groups. So in the Parnaíba River Delta, that's the study area of the present pieces, is the largest open delta from the Americas that is located between the climate transition of humic Amazonic and dry semi-arid climate along the Maranhão, Piauí, and Ceará states that cover 10 cities along these states. And due to his social and environmental importance, it was created an environmental protection area of Parnaíba River Delta. And is also located in the third largest mangrove forest that represents 7% from the world. So it can be the main source of organic matter to the environment. And in his hydrographic basin has multiple uses, such as irrigation and for human supply. But besides these environments, is considered conservative, there is some studies that show evidence of trace metals and nutrients inputs to the environment by anthropogenic source. So the interaction of trace metals with organic matter in these areas have been heavily studied, and the pathway of these parameters along this environment can be a little difficult to delimit because they strong influence on the physical chemical parameters and the biological process. So the hypothesis of the present study is that trace metals from natural and non-natural source can be controlled by the dissolved organic matter in this mobility and partitioning, which can act as a geochemical carrier under geochemical and hydrodynamic conditions of the Equatorial estuary of Parnaíba River Delta. So the general objective is to correlate the organic matter with trace metal distribution and partitioning in the estuaries water of the Parnaíba River Delta. My thesis was divided in 4 chapters. It's the 31st of scientific papers, and the last one it's additional chapter. And the first one, research strategy, answer the specific the first research strategy is about review of trace metals fates. Answer the specific strategy about the trace metal distribution and the environmental compartment that's sediment, water, and biota in estuaries of the Equatorial Brazil Northeast. The second research strategy is about trace metal partitioning that answer the specific objective that is determinate the spatial distribution, determinate the geochemical partitioning, and determinate the environmental quality index. The third strategy is about the dissolved organic matter complexation capacity and signatures that answer the specific objective on the composition of dissolved organic matter and complexation capacity of chromophoric dissolved organic matter with trace metals. And the last strategy is the evaluation of size and composition of dissolved organic matter that answer the composition of dissolved organic matter and the complexation capacity of the chromophoric dissolved organic matter with trace metal over size distribution colloidal fractions. So let's talk about the collect campaign that happened in December of 2019. That was made along 13 stations, as you can see here in the map. And we collected the subsurface water with a NISC button, and also we collect additional water for ultrafiltration treatment that directly on the gallon water, and you can see represented by the orange cycles in the map. And we collected the water, the ultrafiltration treatment along a salinity gradient. And also it was measuring the physical chemical parameters, such as salinity, pH, and temperature in each station. Right now, let's talk about the experimental procedures for sample analysis. We use the microfiltration to separate the particulate and the dissolved fraction. And for this, we use the cellulose acetate to determine the suspended particle matter. And after we made the mineralization to determine the particulate trace methods by SPMS. Part of the dissolved water that was poisoned with chlorhydric acid to reach the pH 2, we determinate the dissolved trace method by the SPMS. Another part of the dissolved water that was poisoned with sodium acid, we determinate the dissolved organic carbon by TOC analyzer. Optical properties by ultraviolet spectrophotometer. The dissolved organic matter composition by fluorescence spectrophotometer. And also the complexation capacity by fluorescence sequence that we also use the fluorescence spectrophotometer. For ultrafiltration treatment, we made a prefiltration to remove the particle, the suspended particle matter from the water, and we collected this fraction, the 0.2 micrometer, after the dissolved water that passed by the cartridge, passed by the ultrafiltration system along this three membrane, that's 0.1 microgram, 10 kilodalt, and 1 kilodalt. And we collect the retentate, that's more concentrated fraction from the system, and the permeate. So in the end, it was 7 fractions by station along the 6 stations, totalizing 42 samples from the ultrafiltration treatment. And these samples was also determined the dissolved organic carbon by TOC analyzer, the dissolved organic matter composition by fluorescence spectrophotometer, and complexation capacity by fluorescence quantity by fluorescence spectrophotometer. Right now, let's talk about the results from the first research strategy about the review of trace method phase. From the review, we found studies along published studies in the sediment, water, and the biota, along 13 estuaries, along these states, Maranhão, Piauí, Ceará, and Rio Grande do Norte. And from all this study, it's a scattered data of metal in the water compartment, but the sediment, it's very well studied, mainly in the Ceará states, that has the biggest amount of study of these contaminants. So the sequential, it was found with sequential studies of trace methods in the sediment. And they give us information about the occurrence and mobility of these elements in the sediment. So which was made the sequential extraction of trace metal bonded to easily exchangeable iron manganese oxides, organic matter bonded to organic matter, bonded to carbonates, and also to residual fraction. And here are the representation of some estuaries of Tibiri, Paciência, and Banca that are located in the Maranhão states, and the Jaguaribe and Pacoti located in the Ceará states. So observe that the trace metals are more associated to the residual fraction, as you observe in Tibiri and Jaguaribe estuaries. It was also found barium bonded to carbonate in the Jaguaribe estuary. It was found zinc bonded to iron and manganese oxides in Paciência estuary. And also we found chromium and lead bonded to organic matter in Paciência estuary, and copper in the Banca estuary. So it's notable the association of these trace metals to iron, manganese oxides, organic matter, and carbonates that can act the main geochemical carrier of this element along these estuaries in the sediment. So so the concentration of trace metal is not enough to give us the anthropogenic input. So we use the geochemical index to evaluate the degree of the contamination of this element in the environment. So we determine by this formula that we use the division of the concentration of this element in the sediment divided by the multiplication of the geochemical background and the constant 1.5 that analyzes the natural fluctuation. And this index gives a variation contamination of one contaminate that represents the class 0 and extremely contaminated to the class 6. And the regional background that we used was from Parnaíba River Delta, that is already published by Paulo Filho in 2015. And the concentration of this element in the sediment in the background, the regional background, we normalize it by aluminum because it don't suffer partitioning easily in the environment. And it's also associated to aluminum silicate in the thin particle in the system. So we apply these. So we apply the concept, this index on the concentration of trace metals in the sediments from the review, and we used the concentration of trace metals, the maximum value, because there is some studies that show minimum and maximum range, or just the mean value. And here the environmental assessment for lead, copper, chromium, and zinc. And we show that in Banca, in Maranhão State, is moderately to heavily contaminated for lead and moderately contaminated for chromium. And Curimataú in Rio Grande do Norte state was moderately to strong contaminated for copper and heavily contaminated for lead. And Parnaíba River Delta was classified as moderately contaminated for lead and zinc, and heavily contaminated for lead, zinc, copper, zinc. And so we observe that even the Parnaíba River Delta is considered a conserved environment that has a primitive condition. It presents anomaly values of trace metals similar or higher than urban estuaries, as I mentioned, the Banca and Curimataú environments. So that's one of the reasons that I choose this environment for the present thesis. And right now, let's talk about the result for the second research strategy about trace metals partitioning. Here are the spatial distribution of the physical-chemical parameters measuring in situ in the collect campaign December 2019. And you observe the salinity, pH, temperature, and the suspended particle matter. And we observe that salinity and pH show a longitudinal gradient in the main river, and by the dilution of the fresh water by the seawater influence. And this dilution is also observed to the west side of the environment. The temperature, I don't know if it's not possible to see, but it show homogeneous value variation that almost don't change along the environment, but it's common in the equatorial ecosystem that don't show temperature significant temperature variation over the seasons. And below the suspended particle matter that is giving the milligram per liter shows similar concentration along the station, but also show a high value in the tutorial bay that may relate by the suspension of the sediment from the bottom to the water column. After some statistical analysis, we identify different zones along the Parnaíba River Delta, which the first one we determined as the main river, it's composed by the Parnaíba River. The another zone is the mangrove channel. That's a long mangrove channel that's more straight compared to the bay areas. That is composed for the three big bays located in the west side of the bay. That's composed by the Tutóia, Melancieira, and Caju bays. So here are the concentration, the contents of trace metals and the particulate fraction. The concentration of barium, cobalt, chromium, copper, lead, nickel, and zinc are given a microgram of metal by the gram of the suspended particle matter. And here, the pink color represented Bay areas, the green triangle represents the main river, and the blue square represents the mangrove channel. And we observe that from the most all the variation of these contents, these metals along the saline gradient, there is a desorption trend of these metals from the suspended particle matter to the dissolved fraction with the salinity increasing. This desorption phenomenon happens due to the high ionic state and by the presence of ionic cation that tend to dissolve these metals to the liquid phase. And we observe that barium has a remarkable decrease in the first two stations, the main river, from the sign 0 to the 17. And also, we observe the decrease for zinc in the two first stations, the main river. In the general, the contents of this metal in the suspended particle matter show that barium has the most highest content, and the cobalt is the lowest content in this fraction. And the dissolved trace metals that graphic show the concentration of these trace metals in microgram per liter, and the dashed line represents the theoretical dilution curve in the station P01 if salinity 0, and P03 if the salinity 36 in the main river. So we observe that there is a heterogeneous variation between the zones, and that may suggest there is a different source of these elements along the environment, and that chromium had increased with salinity. In previous studies about the emission fact of some metals in the Parnaíba River Delta, it suggests that the chromium is more contributed for nitrogen source from the water of the soil and sediment in this region. So it collaborates with the dune that present in the mouth of the river that can be possible source of this element to this station. So in the general concentration of trace metals, observe that barium is also show the highest concentration and lead the lowest concentration. After we determined the distribution coefficient, that it gives me information about the migration of these elements for the particulate to the dissolved trace metal contents in this in the water column or the subsurface water that I collected. So it gives me information when the distribution coefficient is higher to 5. It indicated that trace metal prefer to be bind to the solid phase. And when log below to 3 is preferentially present in the liquid phase. So I applied this coefficient to my results, the subsurface water, and we determined that barium was the weakest associated to solid phase, and chromium was the strongest associated to solid phase. So it indicated that barium is more labile and potential mobilization to the liquid phase, while chromium is less potential, has less potential mobilization to dissolved fraction. When compared our results of distribution coefficient with another environments around the world, we observed that is our results it's a little slightly higher than compared to them. It indicates that all metals are more bold to associate to the suspended particle matter than the others environment. So it indicates a less potential mobilization for this region in the general. After, we determinate the geoaccumulation index for the contents of the metals in the suspended particle matter. And we observed that lead, the suspended particle matter was uncontaminated for lead. The chromium and copper were uncontaminated to moderate contaminated, and zinc was considered to moderate contaminated the suspended particle matter. So it gives them information that zinc may give us a bad environmental quality, that in previous studies about emission effect indicate that zinc are more like a derivative from anthropogenic contribution, mainly by untreated domestic influence and livestock activities. And we can also observe that the zinc show a higher degree contamination in another station that's classified as moderately to heavily contaminated. So it indicates, in the general, indicate that leach was the lowest give it. There is no don't give a bad environmental quality, but the zinc is the highest one. Right now, let's talk about the research strategy. The research strategy about dissolved organic matter complexation, capacity, and signatures. So the fluorescence happens in organic compounds that absorb and emit radiation about a referent fluorescence component. And the parafac give, and this information can be given by the parafac decomposition, that this process many 3D fluorescence emission excitation matrix into a common fluorescence signature. So, and we accept the components with a concordia of above 60%. So, the concordia that we found for the 13 station for microfiltration, the spatial distribution, we found the concordia was 60%, and we found two components. The first component is the PKM, according to Kobe, that's related to marine humic acid. That's more related to autochthonic source by biological activities. That is not preservedly along the time and spatial distribution in the system. The second component is composed by the PKA, that is the fulvic-like, and the PKC that's related to humic-like. And these two peaks are derived from the autochthonic source as a microbial oxidation, this is the PKA, And the pixie is more from terrestrial, allochtone source, that's terrestrial source, or from the mangrove. And when we plot all peaks to the chart of change 2003, that he divided the fluorescence in 5 regions, and we confirm that all peaks are from humic substance of marine, humic acid, fulvic acid, and humic acid. So after we plotted the contribution of each fluorescence of each station, and we observed that for both components, the mangrove chain give us the most significant contribution for the environment. So the dissolved organic carbon show conservative behavior in the main river that increased from the river to the seawater. But this excess of dissolved organic carbon in the mouth of the main river may be from the contribution of dunes that increase this concentration. And the west side of the bay, or the Estuaries area, also show a high value that may contribute the contribution from the fresh water from the background water in this area. When compared all concentration of dissolved organic carbon with another environment around the world and the Brazilian Northeast, we observe that our concentration is a little higher than the other environments. It may be possible by the location of the equatorial zones that has a more primary productivity that increase the concentration of dissolved organic carbon in the water. The absorbance measurement optical properties give us the first graph is the absorbance at the wavelength of 254 nanometers that give us the concentration of chromophoric dissolved organic matter. So it shows the shift of terrestrial chromophoric dissolved organic matter to the microbial dissolved organic matter. So each collaborate with previous studies that was made in the sediment core that give us information that the organic matter in the sediment is more related to terrestrial C3 plants, that is from mangrove, and by the relation of the carbon and nitrogen and the carbon isotopic signatures. The second graph is the specific ultraviolet absorbance. It gives me information about the aromaticity degree of the dissolved organic matter. So it shows the mixture of the high and low aromaticity of these chromophoric dissolved organic matter. The relation of A2 and by A3 give me information about it's inversely proportional to the molecular size. So it shows the dominance of high molecular weight characteristic from the terrestrial source. So in the general, the dissolved organic matter is may dominate from the mangrove with high aromaticity and high molecular weight. The fluorescence quantity technique was used to determine the complexation capacity. So it was incremented different concentration of copper in 15 cuvettes of the samples, the sample from the Parnaíba, and it covered a large concentration of trace metals. So we used the model 1-1 stability conditional by Ryan and Webb for 1982. and give me information that there is a free metal, and the free metal ligand to the one ligand that and the ml. The graph here don't show the formula, but it represents that one ligand complex with one concentration, one metal. After we optimize our model to observe if our experiment fit into our model, and we fix it at pH 6 to avoid the speciation of the metals along during the process, and also to allow us to give a better comparison between the different samples, as we have from seawater and the freshwater one. So here are the representation of complexation capacity against the stability constant quantity, and we observe that in the Bay Area and the main river, they are more similar between them, that show lowest complexation capacity and low stability constant. And the dynamic in the mangrove chain is higher complexation capacity and complexation stability, and the highest stability constant quantity. So it gives us information that there is a stronger interaction between the dissolved organic matter with copper. So it may suggest there is a low availability of the metal, that's the copper, into the subsurface water in this zone. So right now, let's talk about the last research strategy. This is the evaluation of size and composition of dissolved organic matter along the size distribution. So here, the size distribution of dissolved organic carbon and complexation capacity of dissolved organic matter with copper. So here, the mass balance, the mass balance for these parameters along the saline gradient, and we observe that this data is show unlabeled data, because we use the criteria of 100% if the standard deviation of 10. So from the mass balance, we observe there is a loss of this parameter, increment of these parameters during the membranes. It may occur by because the ultrafiltration procedure took a long time to do the filtration. So it may contribute that the organic matter could be condensed or break during this process. When I plotted in the proportional size distribution, we observed in the blue color the dominance of 1 kilodalton that is related to truly dissolved fraction. But as our recovery of the mass balance is not so good, so it's not. It's complicated to assume the dominant molecular size cutoff for these parameters. So after, we also made the composition fluorescence by Parafac for each station front of filtration, and we found also the marine humic-like, fulvic acid-like, and a new signature of protein-like that you can see in the station P01 and P03. This may occur during the microfiltration. We used many fluorescence emission and citation matrix that may overlap this signature, this fluorescence signature. Or during the ultrafiltration treatment, we may could concentrate this component in the samples. And the protein-like are related to autochthonic source, biological biological process. And after the recovery mass balance showed that only the station P17 and P620 at high salinity of 35 and 36 were acceptable. And also, these components are more, the proportion are more in the truly dissolved fraction, as you can see here in the graph. So the conclusion is that salinity acts as a factor on the trace metal partitioning that dissolves the contaminants from the suspended particle matter to the dissolved fraction. That you can see that is remarkable for barium and zinc with potential mobilization, and zinc show a bad environmental quality. And that dissolved organic matter is composed by humic substance, that is for marine humic-like, and fulvic-like, and the protein-like. And these are more contributed by mangrovetanium, this more significant, that show a strong complexation with metals that may alter the exposure of this contaminant in this part of the Parnaíba River Delta. And that salinity also play an important factor in the size distribution of the dissolved organic matter along the molecular distribution, and that be dissolved until the truly dissolved fraction. So the general conclusion is that a quality of the dissolved organic matter from the mangrove act as a geochemical barrier on the trace metal partitioning, that organic matter has a strong complexation capacity and high aromaticity over the salinity variation in the equatorial estuary of Parnaíba River Delta. Right now, for the future studies, I propose a study about complexation capacity of dissolved organic matter with zinc, because it showed bad environmental quality and that it was weakly bound to solid phase or to the particulate matter. And also because this and previous studies show that is from anthropogenic source. For the ultrafiltration treatment, we propose the use of viva spin tubes. That is a faster, there is a faster procedure than the cross-flow ultrafiltration, and it will give me a better comprehension the partition and the size distribution of the organic matter over the molecular size. That's why we made a collect campaign the last December of 2021 to use this methodology. It was in Parnaíba River Delta. And the last proposal is to determine the qualitativity and the quantitativity of organic matter in the mangrove sediment to observe if it acts as a source or a sink of the organic matter to the water column, and to observe this partitioning between this compartment. So right now is the schedule. I started the PhD in 2018, and I did collect campaigns and laboratory analysis and data analysis during all the year, and elaborate the doctoral thesis that is composed by the scientific articles that I intend to publish soon. And during the PhD, I participated of some course publication. I made some publication as first author and co-author. I was co-advisor of Wesley Santos from Bachelor in Oceanography in Universidade Federal do Ceará. I did a teaching internship I participate for some events, and I participate also in collect campaigns in Brazil and in France. So I would like to thank you, the Universidade Federal do Ceará and Université de Toulon, and my colleagues from the Laboratory of Biogeoquímica Costeira and the Mediterranean Institute Oceanography for the help, and also the Pronex, FUNCAP, CNPq, CAPES e COFECUP by the financial support. So, merci beaucoup, thank you e muito obrigada.
Thank you very much, Thais, for your interesting and enlightening presentation. First, I have to say that the two rapporteurs, Professor DAVRANCHE and Professor Rozane, agreed on the good quality of the work presented by Ms. Santos and recommended this presentation. And then now I invite the two rapporteurs to present their considerations, starting with Professor DAVRANCHE, please.
Thank you, Mr. President. So Tahis, thank you also for your oral presentation. That was of very good quality and offer a new light on your result. I think that I misunderstood some of your learning from your manuscript. So generally, I found that the manuscript was well written, but as I said in my report, I found that there is some error in the presentation. I like theses that are report of article. Yes, it's not a problem for me. Yes, but I found that the reference have to put in the end of the manuscript, because when you read the text is cut by the reference and not fluent. It's the main point. So now, considering the scientific part of the project, my first question is about barium. Why did you consider that barium is a metal?
Como? You asking if the barium is a metal?
Yes, if it's a metal, and yes, why you consider in your work that barium is in the whole group of metals?
Oh, I use barium because it's a trace of biological activities in the seawater mass. So I consider it as a metal, as the other elements that I use in the present study.
Yes, but because barium is not a metal. He has not the same behavior. Okay, so I think that in the manuscript you have to precise why you studied barium. Okay, and barium has not a strong affinity for surfaces or for solids. So barium is generally as carbonate, yes, for example, in the solution and not complex to surface. So you have a very different behavior than metals.
Okay.
For me, yes. I have also a question considering the characterization of of the particulate fraction as well as the dissolved fraction. Why did you not provide in the manuscript the concentration of the major ion, such as aluminium, iron, calcium?
Are you say about the highest elements? I use it the salinity, in fact, to be como é que eu sei? A trace of water mass in the environment. So it's giving me if it's sorry. So
yes, no, yeah, I understand. I understand your response. Yes, you consider the whole group of the Majorian by the salinity. Okay.
yes,
Yes, it's okay. But you have in the particulate fraction as well as in the dissolved fraction, perhaps you can have also colloids, iron or aluminium colloids. Did you consider this phase, these colloidal phases in your study?